right, well, it's 1:20. I'm going to start out. I got in this habit visiting India, where everybody shows up 15 minutes late to everything. Was that after breaks, preload the break with information that's not completely critical to everybody understanding things, and then hope by the end of the week that everybody realizes that we start talking on time. So I'm Brendan MacLean. I joined this lab almost 9 years ago and started this project, Skyline, for Mike. Definitely it was his and Dan Liebler's idea to build some tools for SRM, MRM, method development, and data analysis. And originally in Mike's mind, those were 2 tools, and I was like, no, that's 1 tool. And then people would be telling me like, oh, when you're done with Skyline, then you should actually do some a tool that does MS1 data analysis. And what about this new, other thing? And I just kept going, yeah, that's Skyline. That's Skyline. And so that's how Skyline got to be what it is. It does a lot, and I'm going to start talking about all the things it does. But first, just to make sure you're all awake after lunch, how many of you came to Seattle expecting this weather in July? All right. Well, you're well informed. Are there others of you that you have discovered our secret 3 months out of the year? This is what we get very frequently: July, August, September, and then the other 9 months we get a lot of rain, and that's what everybody hears about. But it's a great vacation destination this month, and that's kind of why we decided to put the course in it. And so hopefully you'll enjoy that this week. Okay, another question. How many of you have actually used, or I guess maybe I'll flip it around. Who hasn't used Skyline before? Okay, still a fair bit. I attended my first course in February in San Francisco where everybody had used Skyline before, which was kind of stunning. Since when we started, it was, the majority of people hadn't used Skyline before. So yeah, we're gonna start fairly slow and ramp up, and so hopefully we don't just lose all the people who've never used Skyline before. And yeah, so this is how I view what we're trying to do with Skyline is this chromatography-based quantification. So that I said people came and said, oh, when you're done with Skyline, maybe you can do some extraction of MS1 chromatograms and analyze DDA data, and I said, oh, well, that's going to be Skyline. I've also had people come and say, hey, can Skyline do TMT? Can it do spectral counting? Can it, and those things are sort of off limits because they're not chromatography based. And so everything that Skyline does is extracting chromatograms from this is the 3D space that we are. If you've done mass spectrometry, you should be getting very, very comfortable with this idea that mass spectrometers run over time, produce this 3D space of intensity, mass to charge ratio, and retention time, and there are actually even newer mass spectrometers that produce a 4-dimensional space with ion mobility, which I can't really draw here. But then what Skyline and lots of other tools do is pull chromatograms out of this, so that's a time intensity slice out of this 3-dimensional space at specific mass to charge ratios, and then those are all displayed like this, and we calculate the area under these curves as a proxy for peptide abundance or molecular abundance. Skyline's actually starting to work for small molecules, which unfortunately we haven't really worked that into our curriculum yet, so we're not going to address small molecules too much in this, but a lot of the things still apply. The intensity, who knows what, actually maybe you learned from Tina's talk, what is the intensity value? There's no actually units on here. What is the intensity value on most mass spectrometers? What are they calculating? Ions? It's actually ions per second. So they're calculating a flow of ions, and so if over time we then multiply ions per second by the number of seconds that we did that and take that area, then that's a proxy for the number of ions. And we, we don't just use that, oh, what were the number of ions that came out of my mass spectrometer? That was the point that I was trying to make with Mike, is that you actually have to, like, it's meaningless to say, oh, I saw, this many ions flow from my source, over, in this experiment. We still need to calibrate it to some absolute value if we want to be able to talk about it between labs. Within a single experiment, we can certainly use relative abundance of multiple ions. But so, as I said, we started with SRM, so selected reaction monitoring with a triple quadrupole Skyline, and then have since added PRM. And so Tina, I think, explained all of these. Parallel reaction monitoring was our first sort of like realization that we could do this type of mass spectrometry without a triple quadrupole. And I came into Mike's lab and I was like, wow, we are like a leading, SRM lab, and we have one triple quadrupole. We have like 4 or 5 other instruments. And Mike was the one who said, oh, well, we could actually do the same thing. And we started doing what we were calling targeted MSMS. Now gets called PRM thanks to Josh Kuhn's lab. And then, we also started playing with DIA, and then the Aerosol lab released it at ASMS as SWATH, and so that's this other thing that you're going to learn Thursday. You will learn all, that's the DIA day, as we say, and you're going to learn lots about DIA then. And then finally, with your DDA data, you can also extract chromatograms out of DDA and use them similarly. So. And then we'll talk about that and address that, I think, on Friday. So Skyline as a project it's almost done with its 9th year in development. We're about to enter the 10th year starting in August. There are 6 developers, over 500,000 lines of code. It's all open source, and we take great pride in having been able to offer it completely free for all that time. It's got 60,000 lines of code for testing. We do really extensive testing and try hard not to ever break it. And then we've got over 9,500 registered users. I actually checked, there's over 10,000 sort of active email addresses on the Skyline website, but only 9,500 of them receive release announcements. So I figure anybody who's turned off release announcement really doesn't care about Skyline, so we're not counting them. And then over 8,000 instances generally started in a week. The original paper has gotten over 1,000 citations, and it's funded by our NIH grants, and all of the instrument vendors now contribute funding, and we work closely with them. And then this is a graph over time. It's not actually the complete graph over time. I actually lost our web server right here. And so I don't have the original beginning of time for the graph, but this is up till yesterday, and I like to say that if I've learned anything quantitative over nine years, it's that not a lot of mass spectrometry gets done between Christmas and New Year's, and that's repeated. The very first year I was like, where did everybody go? But that's been repeated. There are other patterns in here. But mostly I look at this just to sort of, see that people are still using it, and get a sense for there are things that you can look at, like all this blue up at the top are people that are using something called Skyline Daily, and we're actually going to have you use Skyline Daily on Thursday because some of the newer DIA methods require Skyline Daily. Skyline Daily is actually a misnomer because it's released about weekly or every few weeks, but I reserve the right to release it on any given day, so it's called Skyline Daily. And so I feel like it's a great compliment that this bar is that wide, because those are the people that basically trust us so much that we're not going to break this tool every time we release it every 2 weeks. I mean, this is just our live development. That they're willing to use it, and you actually see this band get wider as we have longer cycles. So this was a particularly, each color here is a new year. This is a particularly wide cycle, and we saw a growth in Skyline Daily use as we got farther and farther away, and people start going like, wow, there's lots of cool features in there. I want those, and I'm no longer content to just sit here and use Skyline 3.5. I want Skyline 3.6 the way it is right now. And so they run side by side. You're welcome to use both or one, but lots of labs just completely get on Skyline daily, and that's a way that you can try new features and give us feedback and be really connected with the development environment. Or if you want to feel safer, you can definitely stay in the main releases. We can also see trends like the lighter colors are actually 32-bit computers, and so you can see that as a field we're moving from 32-bit to 64-bit computers, and we're actually going to stop Skyline support for 32-bit soon, but at this point we support both. This is website accesses over the last 6 months. You can see that United States by far is the most active. It's a really washed out image here, but here's the United States. This is Seattle. So you this week you'll help contribute to this big blue spot. Otherwise, it's mostly just me. No. But yeah, there's actually a really big blue spot here also. That's Zurich, where Tina comes from. We work very closely with the aerosol lab, and there's a lot of collaboration there. And there's a pretty big spot you can see the edges of that's Cambridge, Mass, Boston area. But yeah, we're also really pleased that we've seen uptake in the Far East and down in Australia and India, which Tina and I visited together a few years ago. And yeah, we've done a lot of teaching. Yeah, there really was a time where I just realized, wow, if this is going to keep growing, people need to learn how to do this. And 2013 was when Tina and her colleagues started that first course. And then in 2014, they did another course, and we added Seattle, and another former aerosol lab member started one in Barcelona, and we've been teaching pretty hard ever since. And so here we are this year at Seattle. We've got Barcelona left, and workshops in Dublin and Philadelphia coming up. The plan is just to sort of continue at this rate. So if you feel that this is valuable to you in the end, we encourage you to encourage your colleagues to come join us for one of these things. And we certainly feel like they're very useful to us. I feel like I always come back with ideas from the people who attend the courses. They'll be like, just even the problems people run into, to be surrounded by a group of people trying to use your software is very enlightening. So happy to be here. And at Skyline we spend a lot of time trying to make sure people can use this software. We have a support board that we've gotten a lot of positive feedback on, and we've written 14 tutorials. 9 of them have been translated into Chinese and Japanese. That's an attempt to reach those Far East people. And then we've been doing these webinars. Started up the very first 12-month period and did 10, and now we've slowed down a little bit, and hopefully we've done 2 this year. Hopefully we'll have 4 by the end of the year. But yeah, those are a great way. We like people to. They're all recorded. You can go online and watch them, and they're actually organized like some of the sessions that you're going to do here. They're organized so that you could follow along. And if you go like, he totally lost me, and I couldn't keep up with him at here. Well, the great thing is about the recording is you can just pause me anytime and catch up. So as I said, we work with these 6 instrument vendors. All have great collaborators at all of them, and they help fund the Skyline project. And since the beginning, Mike's lab is entirely thermo, but we were part of the CBTAC program, which is a large consortium. It was clear that we had to build this software to serve at least Agilent, SciAx, Waters, and Thermo, which were all part of the program. And so we went right out and immediately met with close collaborators that were using SciAx, and then extended to Agilent Waters, and then Shimadzu and Bruker came along, and they were also interested. But one of the great things about Skyline is you can use it on any instrument, and now after 9 years, I've seen a lot of people transfer labs and find that they can transfer their knowledge of how to use Skyline to whatever instrumentation the lab has, and it's also been kind of fun that people who've built up the kind of Tina obviously has a ton of knowledge, but I've seen people who've been very knowledgeable in a place where it was getting used a lot, go to a new place and go like, wow, I'm so popular, everybody wants to learn Skyline from me. So it seems to be a pretty useful job skill for a mass spectrometrist. And so this is, I think I created this slide in the first year. I keep it around. This was the the idea behind Skyline was that you would take discovery experiments, and right after this, we're going to do a chalk talk sort of about this. Take discovery experiments. They would go, there would be some way of iterating, and we knew that we wanted to get from discovery to quantitative assay. That was like, yep, that's what we were, hired to do. But one of the things that Mike and I think, came up with was like, well, that's going to take a bunch of iteration. It's not something that just pops out. You don't just run, you really need to get to know what you're targeting and how it performs and try to figure out some things about it. And so building a tool like Skyline was built to do that iteration to get to a quantitative assay. And then the quantitative assay has its own iteration over many, many, many replicates if you've designed a good assay. So this is DDA acquisition is a very primary way of doing discovery proteomics. We're now starting to see DIA move into that space as well, and we're going to talk about that more on Thursday. But is there anybody here who's never done a DDA experiment? Oh, there is one. Okay. Oh, two. Okay, good. Brave people to raise your hand. And then, but most people who've done proteomics have some familiarity with DDA. And so in order to meet all of those people where they were, it turns out that we have, DDA's been around, as Mike said, for 20 years, and we're really good at running these tools, but we have a lot of them. And so we started with a few that we knew well, like Mascot, and I knew the TPP and Xtandem, and then as Skyline became more popular, more people started coming and saying, oh, could you support my pipeline? Could you support my pipeline? And we now support over 20 different pipelines. And so chances are, if you're doing DDA, you can use that DDA in your targeted experiments, and that was the goal. So then sort of getting rid of this little raindrops of discovery experiment, going into this targeted method refinement, we could contribute retention time libraries, those are IRT, spectral libraries. Often now these are just combined into one sort of, the aerosol lab was calling them assay libraries. We think of them just with spectral libraries with retention time. And then just sort of very broad methods, start with very broad, that's the top of the funnel, and move into, and move into these targeted refinement cycle, and then other previous measurements can be contributed to this process. So this is the targeted method refinement cycle. It starts with building a method and then running the method on a mass spectrometer. The building the method takes place with Skyline. That's what you're going to start a little bit later, pretty soon. And then running the method on the mass spectrometer, as soon as the mass spectrometer, the data comes out, it goes into Skyline again for evaluation of the results. So I always saw Skyline as sort of wrapping around the mass spectrometer, sort of building the method that would drive the mass spectrometer, as well as sort of immediately taking the data off the mass spectrometer and providing insight for human beings. And then there's this refine step, which is like, well, we evaluated the results, now we're going to do something to our method, and then we have a new method and we go around the cycle again. And so what happens in that refine box could be just initial assessment of abundance and measurability, like, is it even measurable? Do I think I'm within the linear range? Things like that. And we may find that, yeah, we just can't measure this well enough, and a lot of things drop out at that phase. In our lab, we now do a degradation assessment, so we put things in the autosampler and leave them there, and we measure them once, and then we do another measurement like 72 hours later, and we make sure that we don't see drop-off. And you're going to see some data where that happened to us back in our early days of doing, and it's really pretty disturbing, or it's difficult to get high precision measurements if your peptides are just like dropping out of existence during your measurements. And so this is just it's a much larger problem, we believe now, than we ever expected. And people just doing sort of broad coverage label free are just that's adding noise to their measurements. And so it's harder to get really high precision measurements if you just always have degradation in your measurements. Another thing we look at is digestion. So, it's important if you're building an assay to know when does this, the ideal curve of digestion kind of goes like this and then levels off. And you have to know when that happens, because if that takes 3 days to happen, that might not be a good peptide, because you don't really want to grab your peptide in the middle of its digestion, because then there's going to be much more variance there. The other possibility is that it actually has some sort of drop off, and so both of those can be problems. And so we frequently run a refinement experiment, an assay refinement experiment, to understand the digestion kinetics of all the peptides. And then scheduling on the mass spectrometer, and optimization. Finally, we might do some collision energy optimization or some other type of optimization. And add yours to the list here. You can work really hard on these things, and we have certain assays. One assay in particular, I think, that set out to measure 50 proteins for the clinical lab. Andy Hoofnagel is going to come talk on Wednesday, and the postdoc working on it really worked on it for 2 years. So then also, I guess the next phase is just to give you some scope on Skyline. It's way bigger than you're going to learn. It used to be that I could hope to sit down and show somebody everything that Skyline could do, and that's just not possible anymore. It's expanded even beyond itself, and we now support these external tools. You're going to get to use the most popular external tool. That you can get to the external tools and learn more about them by clicking this button on the install page. And you're going to use the most, or you can actually go to the tool store inside Skyline, and this pops up a list, and you're going to get to use this one, MS Stats, which is our most popular external tool, created by the VTech lab at Northeastern University. And Olga Vitek will be here later this week to talk about it, and you'll get some hands-on experience with it. These are our 6 most popular external tools, which cover various applications. They now actually, this is an old slide. MS Stats is now over 10,000 downloads, but there are things that are over thousands of downloads. So this is, if you know a bioinformatics developer, this is one way that they can get their work up and recognized, is to create a great external tool for doing some kind of post-processing of Skyline data coming out of Skyline. We also realized, I realized from talking to people who are using Skyline a lot, probably people like Tina and the people working on the CPTAC program, I would get on phone calls with them, and they would open up these folders that had like literally hundreds of Skyline documents in them. And so that was when we sort of started to realize that it was becoming important to have ways of storing them and cataloging them and finding them again, and so that was when Mike managed to get us some funding to start this project called Panorama, which is Skyline in the cloud, or on a web server at least, and it allows you to publish fully annotated Skyline documents. The other thing that I found kind of disturbing was that even though people would use Skyline, the sort of state-of-the-art of publication for targeted experiments was to publish the translation list you used and the raw data. And it's like, well, okay, if you process your data with Skyline, you have so much more. And so just this year, we worked with Steve Carr, and there's a new set of requirements for publishing targeted data in MCP, and we made sure that Skyline with Panorama could serve all of those requirements, There are actually more than 46 public data sets now. There's something called Panorama Public, and there's like 70 total. And but yeah, so now I definitely encourage you, if you start doing your experiments with Skyline, to think about when you publish your supporting your supplementary data, to put your data up into Panorama and publish it to Panorama Public, and that's becoming a great public repository. We're starting to use it in teaching these courses. I think Tina mentioned we also use Panorama to build what we call chromatogram libraries, which are sort of the chromatogram equivalent of spectral libraries. You can take targeted experiments and use them to help you do your next targeted experiment. You can store IRTs and relative ion abundances that you measured using SRM or DIA or something like that in a chromatogram library. And then in the last couple of years, we've been working on aggregating lab QC data. So we have something called AutoQC. There's a publication out on it now, and we run it on all of our instruments, and it uploads sort of search. We load PRM and SRM extracted chromatograms up into this repository, and they're sort of search-free QC statistics. So we don't do like a DDA search and just count the number of spectra that get matched to peptides. Instead, we're looking at like peak widths and chromatography, total area under the curve for certain peptides, and that allows us to have a lot more visibility when something goes wrong into what went wrong. And that gets loaded into Panorama by AutoQC, and I've been told by a collaborator at Merck, as well as Mike has said himself, that having it there makes it really easy to deal with tech support issues where the instrument vendors come out to fix something, and they say they fixed it, and you can just go, no, look, it was like this for a year, and then it went down like this, and it hasn't gone back up because of your fix. And they come back out, and, and eventually they get it back to where it was for a year. So if you have longitudinal QC data, it turns out to be very powerful. It also, just like Skyline, there's a free hosted version. It's also developed under open source in Apache 2.0, and so you could get this thing and install it as your own server, or you could set up a project, and you're all going to get to play with the hosted version on Tuesday, tomorrow. Lots of projects. Actually, I'm behind on updating all these numbers. There's over 250 projects. We have some big projects. Panorama allows you to set up your project as a sort of private lab thing, or you can make a public face. So both CBTAC and LINX, and actually this ABRF, are all fairly large data sets. And to your eyes, if you went to go to the LINX URL, you would just see a website, and you'd be like, oh, this is the LINX website. It's all running on top of Panorama. For CPTAC, there's an assay portal, and that's even further. There's like a separate web server that's pulling data out of Panorama, but the mass spectrometrists are all putting their data up into Panorama using Skyline. So locally installable server application, and there's a program for that. We're getting large pharma companies who are very interested in it. Places that feel they need more data privacy, even than there's a lot of security provided in panoramaweb.org, the public version, but if you need your own server, then we have a program for that as well. This is a nice schematic that was in the first publication about Panorama that sort of shows the relationship of Skyline with the refinement cycle that I showed you, publishing up to Panorama, which is a database fronted by a website, so you can go work on the data with the with a web browser. You can apply all kinds of back-end tools. You can run R scripts up on the server, get graphs and other ways of looking at the data, or you can also then just use it as a repository and download the documents and play with them. And we do this all the time. You know, when once we know that an experiment's up there, you want to show an example of something. Somebody says, "Well, oh, show me an example of an experiment with, you know, double labeled standard, N15 and, you know, SILAC labeling," and you just go, "Oh yeah, right. Here's the experiment. And I'll show you." And so, it's a great public repository. Yes. So hopefully this is connected. So the very first time we taught this course here, I realized I looked at the schedule and I'd constructed it with, you know, with my scientist colleagues, and I was like, oh, there's not really enough Skyline, and people are coming thinking that they're going to come away with a lot of Skyline expertise, and so I invented this thing called a SkyJam, and so and it's not on your schedule, but it is scheduled for 8 a.m. for the next 4 mornings, and I describe the Sky Jams are, if you want to go home and be able to get fully above the rim with Skyline, you have to come to these Sky Jams. And so then I have let's see, can I even play it? Well, let's try. Yeah, there we go. So this will be you in front of your colleagues. This will be your colleagues going, whoa, between the legs, and totally slammed up. So that's what you can do if you're willing to wake up at 8 o'clock in the morning and show up here. Otherwise, we're also just going to cover more material, and so, you know, and I'm going to try to be responsive to what's important to you. I think at those 8 a.m. sessions, I can sometimes offer some options. Do you want to learn more about this? Do you want to learn more about that? We usually do an example of calibrated quantification in the morning. We don't really have a tutorial on calibrated quantification, so that's usually like Thursday or Friday. So I encourage you to come to those. And then this is the Skyline team. And actually, we just lost Max with an intern who's gone to Google now, down in the Bay Area. And then Brian is our small molecule guy, does a lot of ion mobility work as well. And he is here today. Nick is back home on the Cape, but he's done a ton of many things. He's done a lot of statistics with group comparisons that you'll play with. He did the entire document grid UI that generates reports, and we call them live grids because you can basically get an Excel spreadsheet, you know, in all kinds of shapes and sizes and filtered, and Nick is the guy behind that. Vagisha started Panorama, and she's here and will teach you more about Panorama and how to get your data up into Panorama, maybe a little bit about getting your data to Panorama Public. She also started this auto QC thing that you put on the machine and it uploads the data into Panorama. And she's been working closely with Josh Eccles from LabKey because we run on top of this thing called LabKey Server. Josh will also be here tomorrow. Nat Brace, you've met, he's back there. Handles a lot of our instruction, is one really made the webinars possible. And he also handles our localization. So, you know, if you like looking at Skyline in Japanese and Chinese, you know, go thank him. Kaipo is the guy behind supporting the 20 DDA pipelines, and he really made that possible. He's made some of the wizards that you'll see for getting your data into Skyline, made it really easy to, you know, for all 4 of those workflows to bring data into Skyline. And Yuval came to us right out of high school, is now finally attending UW as a CS student. He was out of state and really wanted to go to UW, so he's been working for us for a couple of years, and he's done a number of great projects. He's been the primary guy helping people create those external tools for the last couple of years too. And that's that. Questions? Okay. So, then everybody has to wake up. Oh, question. Oh, sorry. We have a lot of things, a lot of directions we're going. Certainly, one big directive is small molecule. We're going to be building out small molecule. That's, you know, pretty much what Brian Pratt is spending all of his time. We got a, I was hoping that it would be out in 3.7, but we're doing spectral libraries for small molecules right now, and we're actually even finding that this. We're starting to think. I was like saying, oh, we should call it all molecule, because like there's like these peptides and proteins that Skyline's known how to deal with for a long time, but like we're actually using the small molecule support for cross-linking. So cross-link studies, there's a new external tool that will help you take a cross-link search with a tool called Kojak out of ISB and load it into Skyline, and then monitor those things. And even though they're peptides, they get represented as small molecules just because their construction is more complicated than a single peptide backbone, and it ended up being easier to represent as a flexible all molecule thing. So that's definitely big. We've got 3 instrument vendors who are really interested in ion mobility. We've been working very hard with them. So like if and that looks really promising from Waters, Agilent, and Bruker now we're just starting up with. So sort of this 4-dimensional separation. It's an alternative to DIA, or it is another type of DIA maybe. Let's see, yeah, and we'll definitely be doing a lot more DIA. We're continuing to really grow Panorama. And yeah, that's all I have off the top of my head. But there's a lot going on, and we're going to continue moving in a number of directions that are interesting to us, and that we're hearing a lot of feedback are interesting and useful to other people.